In this video, I'm going to run through a conservation of momentum question. I'm doing a type 1 question, which will time with your worksheet, and that's an explosion style question. Now, when I refer to an explosion style question, what I'm actually talking about there is that to begin with, the objects will start stationary and together, and then they'll explode and move apart. So in this case, we've got a skateboarder, as you can see here, and he stood on a skateboard. To begin with, neither him nor the skateboard are moving. And then what's going to happen, at some point, the skateboard is going to jump forwards at a speed of 0.3 meters per second, and the skateboard will obviously move backwards or recoil. And what it's asking you to do in the question is to calculate the velocity at which the skateboard recoils. This is possibly the easiest of the types of conservation of momentum questions, because in this case you know that the momentum before the collision or explosion is equal to 0. But let's just remind ourselves of the law of conservation of momentum. So the conservation of momentum states that the momentum before the collision or explosion is equal to the momentum after the collision or explosion. So we know that beforehand the skateboarder and the skateboard aren't moving, therefore they have 0 velocity, and therefore they'll have 0 momentum. So here you can see that the momentum is equal to mass times velocity, and before the collision, if we put that into the equation, we have momentum is mass multiplied by velocity. So our mass is the mass of the skateboarder, which is 42 kilograms, plus the mass of the skateboard, which is 1.8, multiplied by the velocity of them, which, because they're not moving, is 0. So total momentum is going to equal 0. So now we can see that the momentum before is equal to 0 kilograms meters per second, and that will get you the first mark for this question. So now I'm going to look at after the explosion. And you can see here, after the explosion, the skateboard is going to move this way with a velocity of 0.3 meters per second, and the skateboard itself is going to move this way with a velocity of v meters per second, and we need to calculate what v is. So if we follow this through now, we know that after the collision, the total momentum is going to be equal to 0 kilograms meters per second, because that was the momentum before the collision. You remember the law of conservation of momentum. We can also write that the total momentum is equal to the momentum of the skateboard plus the momentum of the skateboarder. So what we can do now is we can substitute in the values underneath this, so we get the correct equation, and hopefully what we'll do is we'll substitute something in for v here and be able to work out what velocity is. So now what I've done is I've written in here that the total momentum, big P, is equal to little m times little v for the momentum of the skateboard, and big M times big V for the momentum of the skateboarder. Now if I include the numbers now, you can see that 0 is equal to the total momentum. We've got a mass of 1.8 for the skateboard, multiplied by the velocity of the skateboard, which at the moment is V, plus our mass of our person, which is 42, multiplied by his velocity, which is 0.3. And now what I need to do is just simplify the equation and find what V is equal to. So now what I've done is I've substituted the numbers in and calculated, so I've done 42 times 0.3 to get an answer of 12.6. And because this is an R on this side of the equation, I had to subtract that from this side, so 0 minus 12.6 gives you minus 12.6 is equal to 1.8 times V. And now I need to divide through by 1.8 to find what velocity is. So now what we've done is we've taken the 1.8 to the other side, so we've done minus 12.6 over 1.8 gives us our velocity. We can see that velocity is equal to minus 7 meters per second. So the negative indicates it's moving in the opposite direction to the skateboarder. So the velocity of the skateboard will be 7 meters per second to the left. And that brings us to the end of the question. You should now try and attempt all the type 1 explosion questions that you've got available on your worksheet.